Following on from the previous video, I deliberately gave you a vague question in that I didn't explicitly say that you had to use theta here, or you had to use this length here, or you had to use this height here. Um, there are times when you have to just look at the problem. You want to know the answer in that you want to minimize the area here, but then you have to decide for yourself which variable you want to set up. You could set up theta, you could set up lots of other, there are lots of ways of doing this, but the point is that they should all lead to the same answer. Okay, but in this problem, we're going to call this length here x. Okay, so we are going to vary this length here back and forth. Okay, but don't forget our domain here would be x being strictly greater than 5, because it makes no sense when x is dead on 5. You're just going to get a vertical line here. Okay, so it has to be strictly less than 5. Okay, so hang on. So to do this, so we want to minimize this area here. So the equation for this straight line here is given by this: y equals mx plus c. So we want to know, well, ultimately we want to know the height. Later on we can get this height times this length here and then divided by 2. So we will have ourselves the area of the triangle, and we will want to minimize it. So the equation for this line here, we want to find out the intercept really. But first, to find out the intercept, we've got to look at the gradient. So let's call this bit here x0. We don't want to call it x for the time being, because if we say that later on we're going to put this into the m here, and then you're going to think that this x here will be the same as this, and that will become x squared. But this x here is different from this x here. For the time being, let's just call it x0. Okay, so we need to find out the gradient. So the gradient would be the height here, which will be 3, divided by this length here. Okay, so this length here will be x0. Take away this length here from here to here, which will be 5. Okay, and then because it's going downhill, the gradient's going downhill, stick a negative in front of it. So this is our gradient. Now we can put this into here. You see, you don't want to call this x, because later on you're gonna merge this x with this. But the thing is, this x here, for the time being, is different from x0. Okay, well anyway, this is our gradient. Let's put it into the m here. So we know that m equals this. So let's put the m into here. So that will then give you mx plus c. Okay, and then well, once you know the gradient, once you know the gradient, you can use one particular point on that line to find out c. So this is your y here. So put the 3 into the y, put the 5 into here, and then blah blah blah. C equals this thing here. So this is x0 here. Okay, so what we have so far is this. What we have so far is that as we vary this x0 here, the height of this thing here will be given by this. It will be 3 plus a tiny bit here. The point is that as we vary x0 here, this will move accordingly. Okay, so now we earlier we called it x0. We can now we can remove the x0, because this here no longer conflicts with this x here. Okay, we can now just call this here x0 x as opposed to x0, because we no longer need this now, and let's just call x0 x. So we are just going to vary x now. Okay, because it no longer conflicts with that y equals mx plus c. So let's discard that x0. So this length here, we're just going to call it x. So we can vary x back and forth, and then the height here will change accordingly, according to what x is. Okay, so that will then take us to this. So the area, well, hang on, bear with me. So this length here is x. This height here is given by this. So we just need to get this times the length here. So that, and then divided by 2. That will then give us the area. Okay. So now what we in effect have a graph of x versus. So we now have a graph of area of the triangle versus x. So we can now vary x back and forth. Okay, and then the area of the triangle would change accordingly. Don't forget our domain here is 5. Okay, it has to be greater than 5. Below this we don't really want to know, and we don't really care. Okay, well anyway, the area of the triangle is given by this. So tidy this up, blah blah blah, tidy it up. It will then give you this. Okay, so now we want to find out when the gradient. So when you get to this stage here, what you have is a graph of area versus x. We are going to vary x. So we want to find out where the gradient will be 0. Okay, so we need to differentiate this. We need to find out we need to find out where the gradient is 0. So we need dA by dx. Okay, so rewrite this thing here as this, and then we're going to differentiate it. So differentiate it, it will then give you this. Okay, and then blah blah blah. Tidy up, it will then give you this, and then tidy up, blah blah blah. So d blah, and then tidy up, and then merge all these together. That will then give you this. Okay, so dA by dx is given by this thing here. Now we want to find out when we want to find out when the gradient will be 0. So set this thing here to be 0. Okay, so that would lead us to this. So because we want to find out where the gradient will be 0, let's times both sides by this bit here. That will then take us to this. Okay, and then from here, multiply everything out. Multiply everything out, it will then give you this. Tidy up, and it will then give you this. And then, well, when you multiply this out, blah blah blah, everything simplifies. Everything simplifies to this. Okay, so when you get to this stage here, you'll factorize it, blah blah. The gradient will be 0 when x equals 0 or when x equals 10. Okay, so we're not done. We're going to continue in the next video. But the point is that, well, we're not done. Well, I'm going to continue in the next video. Okay.